Good day, ma'am. Good day, classmates. So for today po, we will present to you our insights or report about the type checking comparison between the languages of Java and Python, together with my groupmate, Mr. Kamiya. So this is the contents of our report. Feel free to read it. And for the objectives and languages, why did we choose this? The main reason is to be familiar with it because these languages will be in our practical exam soon. For the objectives, explain static versus dynamic typing, strong versus weak, nominal versus structural. We will also show when and where type errors are detected, compile time versus runtime, compare safety, flexibility, performance, and developer experience, and lastly is to demonstrate examples of compile time and runtime type checking. And for the languages, we choose Java and Python because using these two languages, we will be able to show you the difference between these, which we will tackle a brief definition of these words and their differences, starting from static and dynamic. In simpler terms, static typing checks at compile time before runtime happens, while on the other hand, dynamic typing checks in runtime like Python. Next is the difference between strongly and weakly typed. You will be able to understand it more in our code discussion. And lastly is the nominal and structural typing. Nominal types are identified by their names or declared type. Two types are compatible if explicitly declared compatible, while structural typing, the compatibility is based on the shape or available operation. For Python, it uses duck typing, means if it walks like a duck and quacks like a duck, it's a duck. In simpler terms, if an object provides the method's attributes your code uses, the object will work. There's no name type check enforced by interpreter. Next is the language overview. So our first language is Python, which is a dynamic, structural. Like Java, it is also a strongly type. The image here shows that it is a strongly type because Python refuses to implicitly coerce string into integer. This shows strong typing across incompatible types. That is why the output is a type error. And for the language B, which is our second chosen language, Java, is a static, nominal, and strongly typed too. The image here shows that Java can still throw runtime type errors for casts and type arrays. This is a runtime exception called class cast exception because the compiler allows the cast, but it fails when the JVM enforces actual object type at runtime. And for the comparison chart, let us Mr. Kamiya discuss it.
So now let's move on to the comparison chart. This chart summarizes the major differences between Python and Java. Under type checking, Python checks types at runtime while Java checks at compile time. In terms of typing styles, Python uses dynamic and duck typing, while Java uses static and nominal typing. Both languages are strongly typed, meaning they don't allow invalid implicit type conversions like string to number. For type inference, Python offers optional inference through tools or running runtime binding, while Java uses the var keyword for compile time inference. Regarding common conversions, Python performs numeric widening such as int plus float will turn into float, while Java performs automatic numeric widening from int to double, which will turn into double. When it comes to error timing, Python errors appear during execution while Java catches them before execution. Lastly, in terms of best usage, Python is ideal for rapid prototyping, data science, and scripts, while Java is preferred for large-scale, high-performance applications. Now let's move on to the demo or example output.
And for the demo and example output of our analysis and findings concerning the differences of these two languages, I will show you the Python part, and after that, Mr. Kamiya will show you the Java part. We coded it in online GDB for faster access because of its nature to easily share between us. For the Python language, we coded it in 4 different functions so that we can test it more efficiently. In the first function, the checks, the first variable we can see is the variable name, and it is equal to the string 1. So, and the second part is the variable num, which we call the variable name. So it is a dynamic typing because if we call the variable num in the print section and if we run it, it will show the name 1. So it happens in the runtime and it shows that Python is a dynamic typing. What I've said before, dynamic typing happens at runtime. Next one is the function for type conversion. Here in this code, we have a variable dnum, which is a float 12.34, and an int num variable and we call the int dnum by casting it, by explicitly typecasting it. The result will be changed into 12 only because it changed in the runtime. Here in the second part, p plus 2.5, which is an integer plus float number. There is a implicit numeric coercion. The value that will be printed here if we run this code will be 5.5. And below this code, you can see a comment. Python does not allow implicit string plus int coercion. This error is detected at runtime, not before running, because Python does not check types before running the program. Printed output, we show that string of 5 plus 3 cannot be computed because it will show an error, a type error. Like I said earlier, it's the difference between strongly and weakly typed. So it shows that Python is a strongly typed because it doesn't allow implicit string to add into an int. And the next one is the function type inference. Shows how the machine read or how the machine understands the variables. So in Python, since we don't type its data type in its variable, inferred or it reads implicitly. So like for example, here in our code, the variable name Juan, a string Juan, it inferred it as a string. And same as well as in the age, it inferred it as a integer. It shows that the machine read Juan as a string and age 18 as a integer. So this is how the machine inferred in the Python language. And lastly is the function for runtime. So here we have a variable named value, which is equals to string low, and we put it into the try set method. So we call the value to add to the integer 5 and print the number. It will show an error message or a type error example, which said that it can only concatenate string to string and not to an integer. So it happens in runtime, not like Java that it reads before runtime and shows an error message. In Python, it shows error message after we run it. Like I said earlier, Python is a structural typing, which shows adapt typing. So it is best or good fit for scripting, for rapid prototyping, data science, and projects emphasizing speed and flexibility over rigid compile time checks. And for us to compare it or to learn more the different side of our Python or the one we are comparing to Python language, let us, Mr. Kamiya, discuss the demonstration about the Java language.
Thank you, Mr. Cruzy. Now, let's proceed to the demonstration of the Java code. So first off, let's check type checking. Java is a statically typed language, meaning it checks for type correctness before the program runs. In this section, we attempt to assign a string value to an int variable, which is not allowed in Java. Because this code will prevent the program from compiling, it is kept as a commented line. To show what would really happen, we printed a simulated compiler error which displays the actual message Java would produce, which is error incompatible type string cannot be converted to int. This clearly shows how Java prevents invalid type assignments at compile time. Secondly is the type conversion. So the type conversion or coercion is both explicit and implicit in Java. Explicit conversion is we convert a double to an int using explicit casting. This works but the decimal part is removed. For example, 12.34 becomes only 12. If we remove the cast, Java will refuse to compile the code because narrowing can cause data loss. To demonstrate this, we included a simulated realistic compiler error. The error says that incompatible types, possible lossy conversion from double to int. Implicit conversion, we also show how Java automatically promotes an int to a double when used together. For example, 3 plus 2.5 produces 5.5. Then we demonstrate what happens if we try to combine a string and an int using the plus operator in a numeric context. Java does not allow a direct string to int conversion. The realistic simulated compiler error shows is error, bad operand, types for binary operator, plus operator. This demonstrates that Java only allows implicit conversion when it is safe and logical. The next part is the type inference. This section demonstrates using the var keyword or the variable keyword. Even if we do not explicitly write the data type, Java still infers it at compile time, not at runtime. For example, var name is equal to 1, which is inferred as a string, and var age is equal to 18 is inferred as an int. Although var shortened the code, Java still enforced strong static typing. The inferred type cannot change later. And lastly is the runtime type error. The last part of the program demonstrates a runtime type error. Unlike compile time errors, runtime errors occur while the program is executing. We assigned a string to a variable of type object, which is allowed. However, later we attempted to cast that string into an integer. The code compiles successfully, but when running it, it produces the class cast exception. Even with compile time safety, runtime type errors can still happen, especially when working with generalized type like object. A try-catch block was used so the program could display the error message instead of crashing. Now, let's move on to the conclusion and recommendation. Here are the key findings from our comparison of Java and Python in terms of typing systems. First, we found that Java ensures type safety early because it checks types at compile time. This results in fewer runtime surprises and makes Java more reliable for large and sensitive systems. Meanwhile, Python provides greater flexibility due to dynamic typing, allowing us to write code faster and with less restriction. However, this flexibility comes with a higher risk of runtime errors, since time issues are only detected while the program is running. For our recommendation, recommend Java for large performance critical and type-sensitive applications such as banking, enterprise systems, and projects requiring high reliability. On the other hand, we recommend Python for rapid prototyping, AI or machine learning projects, automations, and scripting, where development speed and flexibility are more important than strict typing rules. And lastly, here are the references that we used. For the question and answer portion, here are the two questions that we have for you. First off, how does dynamic typing in Python differ from static typing in Java when it comes to catch type errors? And second is, which language requires you to declare variable types, Java or Python? Why do you think it requires this? And that's all for our reporting. Thanks for listening.